Acrobat basically has become, the what's used in offices, and so if you were to work even in a library or in archives, there's a good chance you might use Adobe Acrobat to perform OCR. OmniPage Pro, I would say, is next to Abby Fine Reader is one of the bigger software packages. Mainly, if all you're going to be doing is OCRing and doing page segmentation, which we're going to talk about in a little bit. It's really been one of the best. I wouldn't say it's the product, but it's one I've used when I've done big scanning and OCRing projects. So it's still going strong. I think they're into the 10th, 12th software version of it. So they keep improving it, and but it is proprietary. You would have to pay for it. Some scanning and OCR considerations. If you read the Going Gray article, it's a really neat article. It's very specific, but basically they talk about, what are the advantages of scanning text that's bitonal. We've talked about bitonal when we talked about imaging, versus grayscale, which is, so bitonal being 1 bit and grayscale being 8 bit, one being lower res and grayscale being higher resolution. And they did a lot of neat tests with this, and they basically found that bitonal actually worked a little bit better, which is kind of funny. It just must be a quirk. I don't understand a lot about OCR software to understand what it's actually doing, on the sort of code level, the software level. But it, contrary to what conventional wisdom would tell us, there is a point of diminishing returns. So one, the higher the resolution, so grayscale is not necessarily better, and there is a cutoff. Basically 400 dpi is about the best. When you go higher than that, again, the same dpi and grayscale seem to have the same effect, that the higher the dpi, there is a baseline, so 300, 400 is what you want, like sort of minimum for scanning where you intend to do OCR. But if you go higher than that, actually the accuracy tends to kind of drop off. And same way with bitonal versus grayscale, again, going from low res to high res, there is a little bit of a drop off in terms of accuracy. You don't want to have it be too bright. You want it to be sort of somewhere in the middle. Again, if the contrast is too high, the software can't read it. If it's too low, you can't read it very well. If you want 100% accuracy, basically it requires rekeying. So if you're going to do that in-house, you're going to have a person that goes in and does that. And I'm hoping in the exercise to just give you a little exposure to that, because there are reasons to do it, depending on the project. If you're working on, say, the Bible, or you're scanning William Shakespeare or some document that's really important, that the words for indexing purposes be perfect, then paying to have it hand done, rekeyed, or done by a vendor is worth it. But in general, most projects, if you're scanning a bunch of office documents, you're just wanting good enough, which is typically something over 90%. That's what you're looking for. But anyways, it goes without saying, anytime you involve humans in looking at documents and rekeying, it gets very expensive. Most OCR will get you about 97% accuracy. When I first started doing OCR, which was in the early 2000s, I don't remember the number, but I do remember that you might get something like just over 90%. And now it's just amazing, like when you scan something and you're like, just you reading it yourself with your human eyes, it's kind of hard to read, and yet the computer can do pretty well with it. And again, it depends on what OCR software you're using. Perhaps some of the free stuff on the web, there are other ones besides Tesseract that are free, maybe not so much, but the ones like Abby Fine Reader, Adobe, OmniPage Pro, they do a really fantastic job. Again, accuracy is based on the letter and not the word, so the actual computer vision is really what we're talking about when we talk about OCR. But when computer vision, or when it's looking at that image and turning it into actual characters, ASCII characters. It does it letter by letter, not by word. It's not until the letters are put together, then it hits some kind of dictionary, and that's when the individual letters are actually turned into words. Limited to materials post 1850, so we're talking about essentially when the rise of when the rise of typed-based books, newspapers, and so forth. Older stuff, it just tends to be harder for it to be read. Certain languages or typesets may be more difficult than others. Tesseract, if you really get into that, and this is really beyond this, I want you to find out what Tesseract is in some of these OCR applications, but to go very deep in this is really beyond the scope of the course. But there are things, if you get into linguists, the work they do, or literature researchers and students, sometimes they're dealing with languages that have no dictionary for doing optical character recognition. So if you're doing a language that's very rare, say some language in Indonesia, I don't know, I'm just making things up here, but a rare language that for whatever reason a dictionary hasn't been developed. In Tesseract you can actually develop that dictionary, and there are people who do that. Small font sizes might require higher DPI. Handwritten can actually be OCR'd, but it's still very expensive and cutting edge. So one of the first applications I've seen of this in my own work when I've gone to conferences is the 1940 U.S. Census, when they just released that a few years ago, the full version of the census. Basically they're waiting for, I guess, what they consider most of the people who had been surveyed would be very old or potentially deceased. I don't know why they wait on it, but anyways, they a research group in North Carolina, I believe, they did a big presentation on how they were OCRing the 1940 census. So lots of data, lots of software that needs to be written and developed and refined in order to process all this data that they're processing. So they basically came up with a way to recognize handwritten letters, which is really interesting because it's hard enough when you think about all the different font sets that are out there. The letter A in Helvetica versus Times New Roman versus Georgia. I mean, there's just hundreds of font sets. That's a big hurdle to jump. Then think about doing handwriting, which handwriting's as varied as humans are. There's despeckling. Sometimes when you have a scan where there's a lot of dots and stuff in the background, this again would be a bitonal scan here, not a grayscale. There's a process when you're scanning that despeckles it, and that will help the OCR run its program over that to get a better read of the individual letters. And what you're trying to do is just create as much relief as possible, so when it sees like this letter O or H, it sees an H, and it can actually turn that into an ASCII letter that's an H. Whereas these little dots up here, it's kind of tricking the computer, and it can't sometimes figure out that this is a 3. This is not a fantastic example, but there are many out there. I can't remember in this presentation. I think I have a slide on it, but if I don't, if you ever, another way that they refine the software to deal with these speckles in documents and letters that are not, letters and numbers that are not written clearly. If you go and buy something online or you register for something, often at the very end, and I'm forgetting the name, I should know it, but I'm forgetting, I'll have to tell you later on, but when it asks you to read this like sort of garbled text, the darn it, I wish I knew it. I could just right now Google it. Let's not do that now. Let's go back to the presentation. But anyways, when you type in that text that's all garbled, what you're doing is basically helping these OCR software programs become better at reading garbled text. So it's essentially giving it better artificial intelligence. So that's enough about despeckling. Despeckling is just a button you would click if you were using Photoshop or OmniPage Pro and you're scanning. That's just something you would do to the text. Settings for printed text. Again, we talked about the difference between bit depth, bitonal being lower resolution, smaller file sizes. And as we saw with going gray, you get just a slightly better performance with that. 8-bit grayscale, higher resolution. Typically want to use it when you have photographs or any images in there. One thing to consider, and I think I'm going to mention this a couple times, but bitonal, I really see that as kind of a thing of the past. We're still using it, and clearly the article Going Gray makes a case for using it. But the problem is when you're doing big scanning projects, like for example we do many of them here, you're often dealing with not only things that you want indexed, so OCR'd properly, but you also want to look at it. So can you really justify scanning things? You could scan it at grayscale, I guess, and then output to bitonal OCR, and I mean there's probably a workaround for that, so you could get the performance of bitonal but end up with an 8-bit grayscale end product. I don't know, there probably is a way to do it, but long story short is that if you're going to put like newspapers, yearbooks, or whatever you're scanning that has text in it, and probably images, you want them to look nice because people are going to look at it along with it being indexed and OCR'd properly. They also want to look at the images and look at the text and have it be easy on the eyes to read. So 8-bit grayscale is what we tend to go with, even though, as the article points out, the performance is a little lower. Color, 24-bit color, where we've used that, obviously we use it when we're doing color images, but when we're scanning text with our vendors, what we've ended up doing is, say we have a newspaper that typically where color is used is on the front page, we might scan the front page separately and have that done in 24-bit color, and then the rest of it in grayscale. When you get into doing a lot of text, this is sort of a sidebar, but we're talking about lots and lots of images with text with them. So you think of one book, if it's a 400-page book, right there you have 400 pages that you're scanning. So you get into sort of a scale of files that you would not have when you're doing photographs. So anyways, the data footprint can kind of skyrocket if you're not careful. So we tend to be kind of careful. We go with 8-bit grayscale, and we tend to keep the DPI reasonable, 300, 400 DPI. So again, 300, 400 DPI. If the printed text is a smaller, 8.5 by 11 piece of paper or smaller, you could do 300. Or excuse me, if you're doing something that's bigger like newspapers, 300 DPI is fine. If you're doing something smaller where the DPI has to be higher, 8.5 by 11 or smaller books, you would do 400 DPI. And again, as I just said, for ease of viewing, 400 DPI is preferred over 300. Deskewing, this would be come up in all sorts of situations where you might have the book be bound and it sort of gets bent when the pages are pushed down and flattened onto the flatbed scanner. There could be reasons why the document from the get-go was never justified correctly. Deskewing will do that. That's software, and that often comes right in the software package. Now, Tesseract, I don't know that it does deskewing. I don't think it does. It would not do despeckling either, because Tesseract, all it does is do OCR. Whereas something like OmniPage Pro, it would probably do deskewing. I can't remember. I think it does a little bit of deskewing and despeckling. Abby Fine Reader, I don't know about that, but Acrobat would do that, and usually Acrobat, when you're doing scanning, you would be using that with Photoshop, and Photoshop does deskewing. So anyways, these are things that if you were to send out to a vendor, they already have a workflow for setting this up, and typically they include it as just part of their process, so they wouldn't say, do you want them to deskewed? Well, that's going to cost you, a nickel a page. They just typically include it. Calibration. This is something I didn't talk too much about in scanning images, but this would apply to images. But basically, it gives you a benchmark for when you're scanning something. There's typically a color scale, and there's also a gray scale, which here it is up here. But that is tied to a standardized notion of what we say red is for a computer, or whatever this color gray is, and it's a way to, when you scan it, to basically calibrate your monitors, but also calibrate the scanner itself so that it is indeed recognizing the color red in the way that you want it. It's not unlike a test tone, which we didn't talk too much about in audio and video. I don't talk about it at all, really, or color bars for that matter for video. Again, it's a way when you're into like serious, large scale and very important collections and things you want to keep a long time. You want to make sure that the calibration of your monitor and your scanner have all been done. And again, if you send out to a vendor, this is something they do all the time. In-house, it's something you should be doing, but you might not, just depending. If you're going to keep the original and you're really just scanning this for access, you may not do that. PDF and PDF-A, portable document format, we just tend to call them PDFs, was proprietary until 2008. So when we were working in the realm of digital preservation, that was always a concern. People would say, well, we just put it in PDF, but at the time there was no sort of open version of PDF. So if your PDF document had become corrupted, it was very hard to know without it being open and doing something illegal. You could not really work with the document format to ensure that it would last, it'd be preserved over the long term. But the same token, because it was proprietary, you also couldn't do a lot of streamlined work processes with, a digital library, scanning, building software that could use PDF. It just was hard to do. So when they came up with PDF-A, which was sort of their open version of their document, the libraries and archives community sort of basically rushed to that and said, okay, that's good. Probably not the best thing we would use, but that's fine if you want to put that in a digital library. And people like PDF because it's really it's got such market saturation in the sense that PDF is just used everywhere the world around. People use Microsoft products would still use PDF. So anyways, it's used, but basically here's a nice visual of it. There is an image, so anytime you're looking at a PDF, there's an image, but then there's also a text layer that goes with that. We have preferred formats, so we're in the middle of a huge text scanning project where we're having images, text-based documents scanned as images, but they're being OCR'd. And what we're considering our master format, we're doing TIFF. Now we could do JPEG 2000, but it's still not really been tested very well with OCR projects. It has been used with like straight up imaging of just like photographs. JPEG 2000 is fine, but for for your preservation master, for text scanning projects, or born digital projects, TIFF is what we consider the master, and then PDF would be your access version. Again, though, there are some libraries and archives that would have things scanned, and PDF's good enough for them. They don't have the storage capacity to handle all the TIFFs. It is jaw-dropping when you're considering like thousands and thousands of newspaper images when you're doing them in TIFF. It's huge. I mean, we're talking about like one PDF image versus one page of PDF versus TIFF. it's almost, the TIFF is 10 to 20 times bigger. So, but as we've talked about with TIFF and images, TIFF is an open standard. It's been around since the 80s. We know what it does. It's high resolution. There's no compression on it. There's all sorts of reasons why TIFF is preferred for the master format. Again, normal PDF. This is something that if you're writing a document in Microsoft Word and you want to create a PDF, you hit your button and it creates a normal PDF. And it looks like the original. It looks like a document. People love PDF. Image of PDF. This would be the result of like scanning. If you scan to PDF, you're not necessarily guaranteed that the PDF itself has been OCR'd. You're seeing it in PDF format, but none of the words in there, if you did a Control F to find a word, it's not going to show up because it's just merely an image. And it's not until you get to what Adobe calls a searchable PDF, and that means where you have not only the image, but you have the text-based text layer underneath. So if I were to do, again, a Control F and look for a word in there, and I'm sure all of you have done it at least once or twice, if not more, in your academic life, you'll see that, yes, indeed, it's been OCR'd, or it was created by Microsoft Word, so it was kind of naturally OCR'd anyways. Again, we just talked about TIFF. Considered a master file format, preservation worthy, no compression. It's a raster image. So it's not a vector image, it's a raster image. We know a lot about it, it's trusted. Again, it was kind of the sort of go-to format until Adobe opened up in 2008. Again, you need to think about your resources and data storage and how much you can afford, but TIFF does get expensive. But at the same token, if you're scanning a bunch of fragile newspapers, for example, and you never want to do it again, the idea of preserving those TIFFs actually might be very cheap when you think that, oh, well, maybe the PDFs become unreadable, or you realize you want something higher resolution and you didn't do it because all you did was your PDF and sort of medium to low resolution. Having those high res TIFFs would allow you to basically go back to the masters and sort of create all those PDFs again. Or say PDF goes out of fashion and you want another access format. Well, TIFF, you have that there, and you could basically batch all those out to a different access format. Book scanning equipment. Again, we have our flatbed scanners that we've already talked about. These planetary scanners, again, this would be like a camera that is shot from overhead. V-shaped book scanners. So let's back up a minute. Flatbed scanner, they in general are cheaper, but they tend to allow you to run the risk of damaging the object that you're scanning. So, for example, a book. Do you really want to mash the book spine down on the flatbed scanner to get a good read on it? Probably not. But if it's just a loose leaf text based document, that's pretty easy using a flatbed scanner. This overhead, a lot of times it allows you, for example, to not touch the object. You can leave the object sort of as it's almost as if it's kind of wanting to close, when the leaves sort of bend up a little bit. Well, when it does that, there's actually some of the nicer units have software built in that corrects for that. There's also ones with cradles, which I don't have here, but I think I have a link to one of the Zeuchel videos on how that's run, and I'll make sure I get it either on the PowerPoint or we'll have it up on the website so you can see it. But it's a really, really beautiful piece of machinery that allows to scan books. Some of these are turning pages for you, so it allows for mass digitization. There's a company based in Rochester, which I don't think it's Zeuchel. I think Zeuchel's a German company, and I think there's another one in Rochester. But anyways, they can scan a book in like a half hour or something. I mean, the thing just flies, and it uses air suction and compressed air to turn the pages, and it's really quite a a wonder to look at it. So there's all sorts of equipment out there, but we've talked about some of this when we did our image, talking about image scanning. OCR and document OCR is used a lot in text. Excuse me, text scanning is used a lot in interlibrary loan, document delivery, and preservation. Interlibrary loan departments have been doing text scanning in some cases way before the library at large, or say a special collections department, started using it, because they needed to just provide access to books. So in a way, kind of a poor man's digital library. They weren't really building digital libraries per se, but they were, over the web, scan an article and you send it off as an attachment via the email. Sometimes preservation departments will engage in book scanning because they've got a book that's no longer really usable. They may fix the book, do conservation work on it, or before they do the conservation work, they might scan all the pages and then do the conservation work, send the book perhaps to special collections, and then just in the online public catalog, they might just put a link to a PDF of the scan that they've done. Digitization on demand is another one. When a book is out of copyright, a patron might want access to a book, and you just scan the whole thing and send it to them. This goes for a lot of work I do on the archives. We're always doing digitization on demand, for images, for like a folder full of documents in there. And again, for access, we also have e-readers, Kindles, and iPads. These are where now access is, not only does the digital library create access, but the actual thing they're using, they're no longer at a PC, like at a workstation. They can literally put it in their back pocket and read it. And this is already kind of old hat, but it's still relatively new. When you think about e-readers, on the iPad or the phone, people are reading whole books on the phone. I don't advise this. Please don't do that. But it is possible to do it. If your eyes are good, go for it, but I cannot handle it anymore. But Kindles and some of the e-readers, heck, the screens look like you're reading print. I mean, it really, they're not backlit. The lighting on them, the light shines down on the screen, if you will. It's unlike an iPad or an iPhone. So really easy on the eyes. iPhones and iPads I'm not as big a fan of, but anyways, I digress. But text is being read and consumed more now than ever. So as I just mentioned, other reasons of the whys of the digital library, you're going to increase access to, if you scan materials, obviously you're creating access to things that you would have to drive to a physical library to get. Things that are born digital, we only just talk about this a little bit in this course, but things that are born digital and things that are scanned, we're talking about a whole other use case for how people are using textual documents. We're talking about linguists that are taking entire collections of books. They might take all of Shakespeare, or I don't know, all of Mark Twain, or census data, and building what are called corpora. And what this is it allows them to do statistical analysis, data mining, and all sorts of really sophisticated computer software, where they're using the software to analyze the texts, so the stories. So digital humanists, if you want to call them that, or people in the digital humanities, are doing projects where they're not really quote-unquote reading the books anymore. They're letting the computer, they're telling the computer what to do, but they're letting the computer quote-unquote read these novels. And so they're able to ask questions about developments in stories or motifs or metaphors, and they're doing it across hundreds of books, and there's so many books that they're doing it. There's just no way, there's not enough time in one person's lifetime, a scholar, to do that, to read it normally. So they're using computers to do that. Same way historians are mining newspapers and doing historical analysis using these software tools, only because of OCR and digital libraries, I guess, but because of OCR, we're allowed to build indexes, and that from these indexes we're allowed to run this software over them and do basically ask questions that could never have been well, they probably wouldn't have been asked, and even if they were, they wouldn't have been able to answer them because there was no software to do it. So this big text databases and document digital libraries are really it's a sea change right now in how people do research. We need metadata. I'm not going to talk too much about metadata. We're going to dive into that into the deep end really soon about that. But just so you know, documents often are very complex because they have an order that they must follow. So you can't read page 1 of a novel 10 pages in. It needs to be collated correctly. And when you have, for example, you've scanned a bunch of a newspaper or a book, there is a collation of that, so those images need to appear in a certain order so that the information that's in them makes sense. And metadata is often used to basically make these what are called complex objects hold together. And I'm not going to get too much into it right now, but as you can see, if you had a bunch of images that were scanned, you would have a reason to keep them in order. It's unlike photographs, where photographs tend to stand on their own. Same way with audio and video, one file, there is no order to that, it's just one file. But when you're talking about hundreds or maybe thousands of files in one document, there does need to be an order there. We talked about TEI a little bit. This is a sort of the brainchild, this metadata standard of the literature field. It's been around, I think, since the 90s, maybe even since the 80s, but it's an XML-based standard, so they use XML to encode typically works of literature, but you could do it with anything. You can do it with business documents, but it's a different process. That's not really OCRing. Typically with TEI, you are encoding by hand using the syntax of XML. If you all have taken XML, you know what I'm talking about. But if you've done maybe a little HTML, we're talking about a lot of angled brackets and computer code, if you will, that's put in there that sort of tags all the words and the, the paragraphs and the titles and so on and so forth to tell the computer, okay, this is the title, Huckleberry Finn, this is a new paragraph, second page, so on and so forth. Or if you have italics, it's telling the computer to read this as italics, so on and so forth. Dublin Core, we're going to talk more about that later, but it's really just a bare bones metadata tag set, and that would be more for creating metadata like sort of a baseline level for a whole document. And it's not in XML. There is a Dublin Core based XML tag set, but typically Dublin Core was sort of pre-XML. Vendor option sometimes can be cheap or the expensive option. It just depends on what your situation is. And there's all sorts of reasons. Some larger institutions, I would say UAlbany is like a medium-sized institution. Sometimes we might scan something in-house, and it could be cheaper for us or more convenient. Sometimes we might go to a vendor. Right now we're in the process of, we got a grant to digitize thousands and thousands of documents. This is all related to our death penalty collection. And we did the math on it, and we theoretically could have done it cheaper in-house, but the time span that we needed, and just for various reasons, we ended up just sending it to a vendor. The vendors are set up to, that's all they do is just scan. That's all they do is digitize. So it just depends. Sometimes if you're just getting started and you're trying to learn how to do this, as we are in this class, doing it in-house is fine. You want to learn how to do it and kind of make mistakes, and this goes for all of the various work we talk about in this class. I think anytime you can do a little bit on your own is a good thing, because learn how to do it, also learn how to mess up, and then when you go to deal with a vendor, typically vendors are never going to pull the wool over your eyes, but if they were, you know enough about it that you've done it yourself. You're like, oh, that's a fair price, or maybe not. That's not, we could do it cheaper in-house, or just go to another vendor. But as I mentioned, with bigger projects as it is in our case here, vendors just serve a purpose that sometimes it just makes more sense to do it. There are also a lot of expertise. The vendors we deal with are really, really sharp people. That's all they do. They go to all the conferences and present there, but they also are going to a lot of the sort of vendor funded, excuse me, not vendor, but manufacturing conferences. So if the OmniPage Pro is a vendor at a certain conference, often they're talking to them, and so they know a lot, not only about the techniques and the sort of standards, but they also know the software really well. And I'm not going to do it here, but I was going to put up another vendor proposal that really should not be made public. I try to keep it as private as I can in the class, but I want you all just to get an idea of what a vendor would present to you if they were to say, yeah, we'll scan your yearbooks for you or whatever you got, and then to see like what does that mean when they say they'll do it, and you know, how do they return it to you? Do they send it to you on DVDs, CDs, floppies, over the internet, FTP, that sort of thing. Again, we've talked about this a little bit, but TIFF is a good format, 300, 400 DPI bitonal, or grayscale if you're going to have photographs. If there's no photographs at all, bitonal is fine. Again, bitonal gives better results, but grayscale is used more often. I think the results are negligible. I think that going with grayscale is fine. If you're going to do TIFF, 300 to 400 DPI, 8-bit grayscale for few photographs or graphic elements. I don't know why I have compressions. I guess I'm just reminding you that TIFF is a non-compressed format. Just remember, compression is for JPEG. All right. So let's talk about file naming. Here's a sort of just a generic sheet I put up here for file naming for, again, I'm assuming that text-based and documents that you're dealing with are going to have some kind of collation to them. So there's going to be a page 1, page 2, page 3, and so on. If there's just one page, some of these file naming schemes are not as important. But when you're talking about like journals, books, newspapers, things that are serials, where not only do they come out monthly, but they go on for years, and each issue has a number, but within each issue there's pages. Your file naming is going to be very important. So we've seen some of this before, where you might have going basically from left to right, or this sort of generic to specific. So we have a project code, whatever that might be. You can't give it the full name. You want to abbreviate things when you can. You want the file name to become so unwieldy that it's truly unwieldy. Like for example, this is already a pretty long one. We did talk about, and I don't think any of you or me in our worst, darkest hours would ever come up with a file name that would surpass what Windows can handle, but I think, I can't remember, it was like maybe over 200 characters. So there is a limit, but anyways, it's more for the sake of us reading these file names. We want them to be reasonable, and I think this is still in the realm of reasonable. So again, going from generic to specific, we have a project code, or what the journal project code, it might have been the funder that you used, or something very generic but really encompasses this whole endeavor that you're involved in. You might have the publication name, again an abbreviation. You wouldn't use the whole publication name. Dates, that would be, again, going from general to specific, so year, month, day. This would be an ISO way of representing it. Page version, edition, section, and page number. So again, we're going from generic to specific, and then here's like what some of those file names might look like. We have the project, I guess, code. It's a number, 069 dash PMV, what the publication is, might be the abbreviation for that, and then the year, and then we're going, December 12th, day 1, and then we have, I guess, the version, and then the page. So, and how you separate all those. So you can see there are no spaces in here, no periods except for right here. I think these look pretty nice. So let's look at another one here. Here's another one that I think we looked at it just briefly in the class. I know one of you did it as your digital library sort of write-up, but the New York State Historical Newspapers Digital Library has a best practices for file naming. Newspapers, so they're all text. They don't really deal with images or audio and video. But again, they have some sort of standards they throw out there. 400 DPI, grayscale preferred, and then they have this sort of naming scheme, again going from left to right, general to specific, the name of the town, whatever the newspaper is, and then we have dates here, and then the page. Article segmentation. This gets kind of advanced, but you can see for a newspaper, if you're wanting to read an article and you want just a column that's written by one person, you can see how it gets kind of complicated because the computer is really kind of dumb. No offense to computers, but they really don't know when they're reading these letters what direction they go. It just starts reading them, and it's up to a human to intervene, or hopefully you have software that can do that for you. And there is software that does it, and I might be able to expose you to some of that hands-on. I don't know if I can find software that will do that that's free. That's the big problem with this class, is that I try to give you software that you all can just download and use. But anyways, the segmentation is that each article, or I guess text unit, goes together, and if you were to search, like I'm trying to think, ProQuest is a big newspaper and dissertations database. If you were to search, like New Hampshire in there, when it brings it back, it just doesn't throw New Hampshire and then a bunch of gobbledygook of OCR text. It actually gives you the article that New Hampshire went with. So this is where segmentation comes in. This is where some of the more costly aspects of OCRing can get, and sometimes I have to admit, for the projects we've been involved in, to spend the time or pay someone to segment the newspapers we've scanned, I don't know. It's sort of open for debate. It just depends on how important it is to you and what the expectations of your users are. Some users just finding New Hampshire in a title, that's good enough, and then they'll just scan the PDF or whatever they're looking at to figure out where New Hampshire was. Access and delivery, again, kind of a different challenge than I'd say with images and audio and video. To just throw it up on a basic web page, pretty easy to do. You could get some PDFs if you've scanned, say, your a journal or books or newspapers or whatever, and you have PDFs. It's pretty easy, as I do with our course site. I can just put PDFs up on the site. But they're kind of difficult to maintain. Again, once you get at scale, like thousands of PDFs, very hard to maintain them. There's no searching and no dynamic browsing. Digital library software, which I'm kind of assuming any work we're going to be doing with digital libraries, we're using some kind of software. We're not just doing like a web page, although a web page could be a digital library. But the pros are it's typically optimized for searching and browsing and managing content. The cons is it tends to require a high level of technical skill and can be expensive. So software that is optimized to do text really well, unless it's just presenting it to you just as a PDF, tends to be kind of costly either to purchase, and that is an ease to use. Usually the ease of use comes at a cost somewhere, and typically that's in the ticket price for the software itself. Or it's usually somewhere in between, where the software kind of costs a lot of money and it also requires a certain amount of expertise, and that expertise comes in. How do you get this complex object? Again, I'm assuming that the document or the text that you've created, whether it be born digital or scanned, is collated in some way, and you need to tell that digital library software to represent it in a certain way. So kind of different issues than, say, with audio and video and images. Here's some text repositories. I'm not going to look at it here in this video, but you can look at them. This Ithaca Library one, I think they have all of their, the Ithacan, which is their student newspaper, and they use a Olive software, like the pickled Olive, OLIVE, and that's a OCLC software, and I think they might host it for them. And then this New York State historical newspapers, which I think Alan and one of you guys did that. Russell and Alan did a review of. That's a really neat project because they're using open source software that was created by the Library of Congress, and that is a very, not only a pretty complicated piece of software to install and configure, but using it is also kind of tricky. I've looked into it, actually us using it here in special collections, and we've kind of put that off for now. But anyways, the project is really neat. You should check it out. I also had it listed off the, I think, the main page as well, the course page. So I think that's, oh, okay. And then two more here. This is a quick one here, the Stanford Digital Library. Take a look at that. And this Zeuchel Perfect Book One. It gives you an idea of, since we're doing an online class, we can't do field trips, but you can virtually go on a field trip and look at some how this manufacturer, Zeuchel, how they do their scanning products, and then the Stanford Digital Library, which is a leader in libraries and doing digital libraries. They'll show you how they do their work there.